Sardinia, Italy. June 12, 1943. American Second Lieutenant William Chalker banked his P-38 Lightning hard left, trying to orient himself after what should have been a routine courier flight from Gibraltar to Malta. His compass had been acting erratically for the past hour, and now, desperately low on fuel, he spotted an airfield below. Relief flooded through him as he lined up for approach. Finally, somewhere safe to land. The twin Allison engines purred as he descended, the distinctive twin-boom silhouette casting shadows across the Sardinian landscape. Chalker lowered his landing gear and touched down smoothly on the runway at Capoterra airfield near Cagliari. Only as he rolled to a stop and saw Italian ground crew racing toward his aircraft did the horrifying truth hit him. This wasn't Malta, this was enemy territory. Within minutes, an Italian military vehicle blocked his path. Chalker opened his canopy to find himself surrounded by stunned Regia Aeronautica personnel. His 30-degree compass error had delivered him and America's most advanced twin-engine fighter directly into enemy hands. The Italians could barely believe their luck. For months, they had been trying to understand how these distinctive American fighters kept appearing over the Mediterranean with such devastating range and firepower. Now they had one, intact and fully functional. The Lightning was quickly repainted in Italian markings, white bands circling its twin booms, Sabaudian crosses on the tails, and flown to the Guidonia Experimental Centre near Rome. There, Colonnello Angelo Tondi, Italy's chief test pilot, would evaluate what the Americans had built. But when Italy's assessment reached German hands after the Italian armistice in September 1943, Luftwaffe engineers discovered something that fundamentally challenged their understanding of fighter design. They discovered that the Americans had solved a problem Germany hadn't even fully recognized. It had. The P-38 Lightning represented not just excellent engineering, but a completely different philosophy about what made a fighter deadly. And that philosophy was winning the war. Angelo Tondi was 52 years old, a pilot who had flown everything from the Great War's fabric biplanes to Italy's newest combat aircraft. He had tested British Spitfires, German Messerschmitts, and dozens of Italian designs. He understood fighters, understood their strengths and weaknesses in the unforgiving environment of combat. When he climbed into the P-38's cockpit for the first time, he approached it with professional skepticism. The Lightning's twin-boom configuration looked ungainly compared to the sleek single-engine fighters he knew, but first impressions, he had learned, could be deceptive. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The P-38 had entered service with the United States Army Air Forces in 1941, and by 1943 it was operating across every theater of the war. In the Pacific, it had become famous for long-range interception missions, including the April 1943 operation that shot down Admiral Yamamoto. In North Africa and the Mediterranean, P-38 Lightning groups had contributed decisively to establishing Allied air superiority, earning the aircraft the German nickname Der Gabelschwanz-Teufel, the fork-tailed devil. German and Italian pilots had mixed opinions about it. Some dismissed it as easy prey, particularly when caught low and slow during bomber escort missions. Others gave it grudging respect as a dangerous opponent that could dictate engagement terms through superior speed and altitude performance. But no one had yet conducted a systematic technical evaluation of what made the Lightning work. Tondi's first flight revealed immediately that this was an entirely different kind of aircraft. The twin Allison V-1710 engines, mounted in the distinctive nacelles extending from each boom, delivered approximately 1,400 horsepower each. That gave the Lightning a combined output of 2,800 horsepower, more raw power than any German single-engine fighter possessed. But it was how that power translated into performance that surprised him most. The Lightning's rate of climb was extraordinary. From sea level, the aircraft could climb at over 3,700 feet per minute initially, maintaining strong climb performance all the way to its service ceiling above 40,000 feet. Tondi, accustomed to Italian and German fighters that struggled to maintain climb rates above 25,000 feet, found this remarkable. He could advance both throttles smoothly and watch the altimeter unwind at a pace that would leave pursuing Messerschmitts and Mackays gasping for air. The Lightning's counter-rotating propellers eliminated torque, making the aircraft stable and easy to control during these aggressive climb profiles. There was no tendency to yaw or roll, no need for constant rudder corrections. It simply went up, fast and straight. German fighters, by contrast, required pilot skill to manage torque effects during climbs, particularly at high angles of attack. The Bf-109's powerful Daimler-Benz engine twisted the entire airframe, demanding significant right rudder input to maintain coordinated flight. Experienced pilots managed it instinctively, but it added workload and complexity. The Lightning just climbed. At altitude, Tondi discovered another advantage. The twin-turbo supercharged engines maintained power output far better than Italian or German fighters as air density decreased. Where a Messerschmitt's performance would drop off noticeably above 25,000 feet, the Lightning's Allisons kept pulling strongly. The turbo superchargers compressed the thin air, feeding the engines enough oxygen to maintain manifold pressure and power output. This wasn't theoretical. It was measurable, significant, and tactically decisive. A P-38 at 30,000 feet could outclimb, outrun, and outmaneuver most Axis fighters trying to operate at that altitude. The German Bf-109G could reach those altitudes, certainly, but it lost climb rate and acceleration. The Lightning retained both. High-altitude interception, a crucial mission for defending against Allied bomber formations, suddenly looked very different when the defending fighter could climb faster than the attacker's escorts. Tondi conducted turning tests next. The Lightning's large wing area, 327.5 square feet, gave it excellent lift and maneuverability despite its size and weight. With combat flaps deployed, a feature that extended small flaps beneath the wing to increase lift during turns, the P-38 could pull tight sustained turns that kept pace with smaller, lighter fighters. German ace Johann Pichler, who fought P-38 seconds over North Africa, later acknowledged that the American fighter in 1943 climbed much faster than his Bf-109. Johannes Steinhoff, commander of Jagdgeschwader 77, admitted that while his older Bf-109 seconds were perhaps a little faster in level flight than the P-38, actually dogfighting with the twin-engine fighter was daunting. The Lightning pilot could dictate engagement terms. Tondi's detailed evaluation documented cruise speeds, maximum speeds at various altitudes, fuel consumption rates, and operational range. The numbers told a compelling story. The P-38G he was flying could carry up to 410 gallons of internal fuel, and with external drop tanks, total capacity exceeded 1,000 gallons. That translated to combat radius exceeding 600 miles, meaning the Lightning could fly deep into enemy territory, fight, and return home. German fighters, tied to shorter ranges, couldn't match this strategic flexibility. Range wasn't just about how far you could fly. It was about how long you could stay in the fight, how much freedom of action you possessed. The Lightning redefined what fighter escort meant, making deep penetration bomber missions viable where they had been suicidal before. The armament package impressed Tondi immediately. Concentrated in the nose, the Lightning carried one Hispano 20mm cannon and 4 Browning 50 caliber machine guns. All 5 weapons fired straight ahead along the aircraft's centerline, with no convergence issues to worry about. German and Italian fighters mounted guns in the wings, requiring careful harmonization so that rounds converged at a specific distance, typically 200 to 300 meters. Get too close or too far from that convergence point, and your effective firepower dropped significantly. Pilots had to judge range precisely. The Lightning's pilot simply aimed the entire aircraft and fired. The concentrated nose armament hit like a brawl and sledgehammer at any range within effective weapon reach. Tondi test-fired the guns over the Mediterranean and watched the devastating effect on a target tug. The 20mm cannon rounds, mixed with 50 caliber armor-piercing and incendiary rounds, created a cone of destruction that shredded anything in its path. Against bombers, this would be devastating. Against fighters, it would be lethal. The cockpit layout was logical and efficient. The control yoke felt responsive without being twitchy. Visibility from the greenhouse-style canopy was exceptional, giving the pilot nearly 360 degrees of situational awareness. Italian fighters like the Mach-E 202 and German designs like the Bf-109 both had significant blind spots, particularly to the rear and below. The Lightning pilot could see threats coming from almost any angle. The aircraft's twin-engine configuration provided redundancy that single-engine fighters could never match. Lose one engine to battle damage or mechanical failure, and the Lightning could still fly home on the other. Tondi experimented with single-engine flight and found that while the aircraft developed asymmetric thrust requiring rudder input to counteract yaw, it remained controllable and could maintain altitude reasonably well. A single-engine German or Italian fighter hit in the engine was going down. The pilot's only option was to bail out or attempt a forced landing. The P-38 pilot had choices, and in combat, choices meant survival. After extensive flight testing, Tondi wrote a comprehensive report for the Regia Aeronautica. His conclusion was unequivocal. The P-38 Lightning represented advanced American engineering applied to fighter design with no compromise on performance or capability. Its climb rate exceeded anything currently in Axis service. Its high-altitude performance was superior across all parameters. Its range and endurance redefined fighter escort missions. Its concentrated armament delivered devastating firepower, and its twin-engine layout provided survivability that single-engine designs could not match. The report acknowledged weaknesses. The Lightning's roll rate, while adequate, was slower than the Bf-109's due to its larger wingspan and twin-boom structure. In certain tactical situations, particularly when bounced from above, this could be exploited. The aircraft's compressibility issues in high-speed dives were becoming known, though the full extent of that problem wouldn't be understood until later. But these were tactical considerations within specific engagement scenarios. The Lightning's strategic advantages, climb rate, altitude performance, range, firepower, and survivability, made it a formidable opponent that changed the calculus of air combat. When Italy capitulated in September 1943, the Germans seized Guidonia airfield and all its contents. Among the captured intelligence was Tondi's detailed P-38 evaluation. The documents were shipped north to Germany, where they landed on the desks of Luftwaffe technical intelligence officers, already struggling to understand how American aircraft kept improving, while German fighters stagnated under material shortages and production disruptions. The intelligence summary that reached Rechlin Test Center near Berlin contained Tondi's performance data, his tactical observations, and his overall assessment. Luftwaffe engineers read it with growing concern. They knew the P-38 was fast and well-armed. Every pilot who had encountered one reported that much. But the detailed performance figures, particularly the climb rate data, revealed something more troubling. The Americans had engineered a fighter that dominated the vertical dimension of combat. In air-to-air tactics, control of altitude was control of the engagement. The fighter that could climb faster could always gain the advantage, choose when to attack, and break off when conditions turned unfavorable. German fighters in 1943 relied on altitude advantage gained through early warning and positioning. They would climb to intercept altitude before Allied bomber formations arrived, then dive down to attack. If American escort fighters were present, the Germans relied on speed in the dive to make their attack run and escape before being caught. The Lightning changed that equation. An American fighter that could climb faster than a Bf-109 could chase down diving German interceptors, catching them before they reached safety. It could also climb above bomber formations and wait, forcing German fighters to attack through a gauntlet of escort fighters that held the altitude advantage. The tactical implications cascaded through every aspect of fighter operations. Oberleutnant Hans-Werner Schmidt, a Luftwaffe technical intelligence officer assigned to analyze captured Allied aircraft, wrote a supplementary assessment after reviewing Tondi's data. Schmidt had access to German performance test results for the Bf-109G, the latest production variant of Germany's primary fighter. He conducted a direct comparison. The Bf-109G6, powered by a Daimler-Benz DB605 engine producing approximately 1,475 horsepower, had a maximum climb rate of approximately 3,300 feet per minute at sea level. That was competitive with the P-38's 3,700 feet per minute, close enough that a skilled German pilot might compensate through superior tactics or positioning. But above 15,000 feet, the divergence became stark. The Bf-109's climb rate dropped steadily as altitude increased. By 25,000 feet, it was climbing at approximately 2,000 feet per minute. By 30,000 feet, it struggled to maintain 1,500 feet per minute. The P-38, by contrast, maintained strong climb performance through much higher altitudes, thanks to its turbo-supercharged engines. At 25,000 feet, it was still climbing at over 2,500 feet per minute. At 30,000 feet, it retained approximately 2,000 feet per minute. Those differences translated directly into combat advantage. If a P-38 and a Bf-109 started a climbing fight from 20,000 feet, the Lightning would gain altitude faster at every stage. The German pilot would find himself looking up at an opponent who dictated all engagement terms. Schmidt's report noted something else troubling. The P-38's power-to-weight ratio, approximately 0.14 horsepower per pound, was competitive with German fighters, despite being a much larger, heavier aircraft. The Lightning weighed approximately 17,500 pounds, fully loaded for combat. The Bf-109G weighed approximately 7,000 pounds, yet both aircraft had similar power-to-weight ratios, meaning the Lightning's larger engines compensated entirely for its greater mass. That shouldn't have been possible, Schmidt wrote. The physics were straightforward. Larger aircraft should be slower, less maneuverable, less capable across all performance metrics compared to smaller, lighter fighters. Yet the Americans had built a fighter that violated those assumptions through sheer engineering excellence and industrial capability. They had simply built bigger engines, installed them in a larger airframe, and produced a fighter that matched or exceeded German performance in the metrics that mattered most. The industrial capacity required to mass-produce engines delivering 1,400 horsepower each, then install 2 of them in every fighter, exceeded anything Germany could sustain in 1943. Daimler-Benz was struggling to produce enough DB605 engines for single-engine Bf-109 seconds. The idea of building twin-engine fighters with equivalent or better performance was economically and industrially impossible. The Americans were doing it routinely, building P-38 Lightnings at multiple factories, delivering them to squadrons across every theater of the war. Schmidt's report concluded with an observation that would prove prophetic. The P-38 Lightning's climb rate advantage represents a fundamental shift in air combat dynamics. German fighters can no longer rely on altitude advantage as a guaranteed tactical asset. American escort fighters can now chase down and intercept German interceptors across the full altitude spectrum from sea level to above 30,000 feet. This changes everything. The report was filed, read by several senior Luftwaffe officers, and largely ignored. Germany in late 1943 was focused on jet fighter development, on the Me-262 that would, theoretically, sweep Allied fighters from the skies through sheer speed advantage. The idea that a conventional twin-engine American fighter posed a strategic problem seemed less urgent than the promise of revolutionary jet technology that would restore German air superiority. But the P-38 seconds kept coming. By late 1943, 3 P-38 groups were operating in the Mediterranean theatre, escorting bombers to targets across Italy, the Balkans, and southern Europe. In England, the first P-38 units were arriving to reinforce the 8th Air Force's desperate bomber campaign over Germany. The fork-tailed devils were multiplying, and German pilots were learning that engaging them required caution, skill, and preferably a significant altitude advantage to start. Without that advantage, the Lightning's climb rate would erase any tactical edge within minutes. Individual German aces developed specific tactics for fighting P-38 seconds. Attack from above with significant speed advantage, use the Bf-109 superior roll rate to evade if the Lightning reacted quickly, and never, ever get into a climbing fight. Those tactics worked, sometimes, for skilled pilots in favorable situations. But tactics that required perfect execution and ideal conditions were not sustainable across an entire fighter force. Average. Pilots in average situations needed aircraft that could compete on roughly equal terms. The Lightning's climb performance meant that rough parity was increasingly difficult to achieve. In the Pacific Theater, where P-38 seconds had been operating since 1942, Japanese pilots had learned these lessons earlier and harder. The Lightning's climb rate allowed it to dominate the vertical fight against Zeros and other Japanese fighters that relied on low-speed maneuverability. American P-38 pilots developed zoom and boom tactics, using superior speed and climb to attack, then climbing away before Japanese fighters could respond. The same tactics were now appearing in the Mediterranean and over Europe, American pilots exploiting their aircraft's strengths while avoiding its weaknesses. The statistical evidence was mounting. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. In North Africa, through mid-1943, P-38 squadrons maintained operational readiness rates above 70%, meaning at least 7 out of every 10 Lightnings assigned to a squadron were flyable and combat-ready at any given time. German fighter units operating Bf-109Gs in the same theatre struggled to maintain 50% readiness, often dropping below 40% due to maintenance issues, parts shortages, and battle damage. The Lightning's twin engines and robust construction contributed to its reliability, but so did America's systematic approach to logistics, spare parts availability, and maintenance training. Pilots reported that the P-38 was relatively easy to maintain in field conditions, a significant advantage in austere environments like North African airstrips where dust, heat, and limited facilities challenged every aircraft. German fighters, particularly later marks of the Bf-109 with increasingly stressed engines running at maximum performance. German fighters, particularly later marks of the Bf-109 with increasingly stressed engines running at maximum performance, required meticulous maintenance and frequently suffered mechanical failures in harsh operational conditions. The disparity wasn't just about engineering quality. It reflected fundamentally different industrial philosophies about what combat aircraft should prioritize. By early 1944, the Luftwaffe had captured or recovered several additional P-38 seconds across various theatres. One Lightning, coded T9+XB, reached Rechlin Test Centre, where it underwent comprehensive evaluation alongside other captured Allied aircraft. The Rechlin tests confirmed everything Tondi had reported and added further details about the Lightning's construction methods and manufacturing quality. German engineers examining the P-38's engines found American mass production techniques applied with remarkable consistency. The Allison V-17 10 engines showed tight tolerances, quality materials, and excellent workmanship throughout. Cylinder heads matched perfectly across both engines. Machining quality exceeded German standards in many areas, despite being produced in vastly larger quantities than anything from Daimler-Benz or Junkers. The turbo supercharger installations drew particular attention. The General Electric turbo superchargers were sophisticated pieces of engineering, using exhaust gas energy to drive compressors that forced additional air into the engines at high altitude. German aircraft used mechanically driven superchargers that drew power directly from the engine, reducing net output. The turbo supercharger, by contrast, recovered otherwise wasted exhaust energy and converted it into additional power at altitude. This wasn't revolutionary technology. Germany understood turbo superchargers and had experimented with them. But American industry had refined the concept, made it reliable, and manufactured it in sufficient quantities to install turbo superchargers on thousands of fighters. The engineering challenge wasn't creating one working system. It was creating thousands of working systems, all functionally identical, all reliable enough for combat operations. The Rechlin evaluation team conducted climbing trials, pitting the captured P-38 against German fighters to measure relative performance. A Bf-109, G6, and the P-38 started from sea level and climbed at maximum power. Through 15,000 feet, the aircraft climbed roughly together, the Messerschmitt's slight advantage in initial climb rate roughly balancing the Lightning's superior power to weight at speed. Above 15,000 feet, the P-38 began pulling ahead steadily. By 20,000 feet, the Lightning was noticeably higher. By 25,000 feet, the separation was pronounced, the P-38 continuing its strong climb, while the Bf-109 laboured in the thinning air. At 30,000 feet, the test ended. The P-38 had reached altitude with fuel and energy to spare, ready to fight. The Bf-109 had barely made it, engines straining, climb rate reduced to a crawl. The test pilot's report was clinical. The American fighter dominates the high-altitude climbing fight. Our aircraft cannot compete above 20,000 feet without significant tactical or positional advantage. Where it joined dozens of other reports about Allied aircraft superiority in various performance parameters. The response was muted. Germany in early 1944 faced catastrophic problems across every front. The Eastern Front consumed men and materiel at unsustainable rates. Allied bombing devastated German cities and industrial capacity. The Mediterranean theatre was collapsing. The invasion of France was imminent. A report about one American fighter's climb rate, however troubling, competed with existential threats for command attention. But to the engineers and test pilots who understood air combat, the P-38's performance represented something more fundamental than a single aircraft's capabilities. It represented an American approach to fighter design that prioritized practical combat effectiveness over theoretical elegance. German engineering culture valued sophisticated solutions, tight integration, maximum performance extraction from minimum weight. The Bf-109 epitomized this philosophy. It was a relatively small, light fighter that achieved excellent performance through careful design and powerful engines. Every component served multiple purposes. Weight was ruthlessly minimized. The result was an aircraft that, in ideal conditions with expert maintenance and skilled pilots, could compete with anything. But ideal conditions rarely existed in combat. The Bf-109 was maintenance-intensive, requiring frequent attention from skilled mechanics. Its narrow landing gear made ground handling difficult, contributing to high accident rates during takeoff and landing. Its limited fuel capacity restricted operational radius. Its single engine meant battle damage often proved fatal. These weren't design flaws. They were conscious trade-offs, accepting practical limitations in exchange for maximum performance. The American philosophy, embodied in the P-38, made different trade-offs. Accept greater weight and complexity in exchange for redundancy, range, and reliability. Install 2 engines instead of 1, accepting the weight penalty but gaining redundancy and total power output. Mount all armament in the nose, accepting the structural challenges but gaining concentrated firepower. Install turbo superchargers, accepting complexity but gaining high-altitude performance. The result was an aircraft that, while not optimal in every parameter, excelled in the metrics that mattered most for winning the strategic air war: climb rate, altitude performance, range, firepower, and survivability. German ace Kurt Bühlingen, who would finish the war with 112 victories on the Western Front, acknowledged the Lightning's strengths while noting its vulnerabilities. He recalled that P-38 seconds were relatively easy to burn once hit, and that German fighters with altitude advantage and skilled pilots could achieve favourable exchange ratios. But Bühlingen also noted the critical qualifier: German fighters needed altitude advantage first, needed to see the enemy formation early, needed to position above and attack from the sun. The P-38's climb rate made gaining and maintaining that advantage increasingly difficult. If caught level or below the Lightnings, German fighters faced opponents who could climb away faster than they could follow. The tactical initiative belonged to whoever controlled altitude, and the Lightning could seize altitude faster. In the Pacific theater, where American pilots had more experience fighting in P-38 seconds, the climb rate advantage proved decisive repeatedly. Lieutenant Thomas Maguire, who would become America's second highest scoring ace, described his typical P-38 engagement tactic. Spot enemy fighters below, dive to attack with speed advantage, make one firing pass, then use superior speed and climb to zoom back to altitude before the enemy could react. The Lightning's acceleration in the dive, combined with its climb rate, created a yo-yo attack pattern that Japanese fighters couldn't counter effectively. German pilots facing P-38 seconds over Europe developed similar respect for the aircraft when properly employed. The key phrase was properly employed. American P-38 units in the European theatre of operations initially suffered heavy losses because tactical doctrine tied them too closely to bomber formations. Required to fly close escort, maintaining formation with slow-moving bombers, P-38 seconds surrendered their speed and climb advantages. German fighters could position above the bomber streams, dive through the escort screen at high speed, attack the bombers, and escape before the P-38 seconds could pursue effectively. This wasn't the Lightning's fault. It was misemployment of a fighter, optimized for different tactics. When American commanders finally allowed P-38 seconds to fly free-ranging escort, positioning ahead of and above bomber formations, with freedom to engage German fighters aggressively, the Lightning's combat effectiveness improved dramatically. Now the climb rate advantage could be exploited properly. P-38 seconds would climb to 30,000 feet or higher, well above the bomber formations, and wait for German interceptors to approach. When German fighters appeared, typically below the P-38 seconds and focused on reaching attack positions against the bombers, the Lightnings would dive down with tremendous speed advantage, attack, then climb back to altitude faster than the German fighters could follow. The tables had turned. German fighter pilot Hans-Joachim Marseille, before his death in September 1942, had noted that fighting was about energy management, about maintaining speed and altitude that gave you options. The P-38's climb rate gave it energy management capabilities that exceeded contemporary German fighters, particularly at the altitudes where bomber escort battles occurred. By mid-1944, German fighter pilots reported that P-38 encounters required extreme caution. Engaging a Lightning with altitude advantage was possible. Engaging one from below or level meant risking a fight where the American could dictate all terms. Most German pilots chose to avoid P-38 seconds when possible, focusing on bombers as the primary target and accepting that some percentage of escort fighters would remain unengaged. But avoiding enemy fighters wasn't a viable long-term strategy. The fundamental mission of Luftwaffe fighter units was to stop Allied bombers from destroying German industry and cities. That required penetrating fighter escort screens, and the P-38 formed a significant component of those screens. The strategic air war became, increasingly, a question of whether German fighters could reach the bombers before American escorts intercepted them. The P-38's climb rate meant American fighters could position higher and earlier, creating layers of defense that German interceptors struggled to penetrate. Production numbers told their own story. Lockheed produced approximately 10,000 P-38 Lightnings during the war, with multiple variants and steady improvements in capability and reliability. Germany produced approximately 33,000 Bf-109 seconds of all variants throughout the entire war, a larger total number but distributed across all theatres and all years. By 1944, German production was severely disrupted by Allied bombing, material shortages, and transportation difficulties. American production, by contrast, operated from factories beyond the reach of Axis air power, with unlimited raw materials and abundant skilled labour. The industrial dimension of the climb rate advantage became clear when considering how quickly lost aircraft could be replaced. An American squadron that lost P-38 seconds in combat could expect replacement aircraft within weeks, often sooner. German squadrons waiting for replacement Bf 109 seconds might wait months. Meanwhile, operating at reduced strength, the Americans could afford to trade losses roughly 1-for-1 with German fighters and still win through attrition. Germany could not. After the war, American technical intelligence teams interrogated Luftwaffe officers and engineers about captured Allied aircraft evaluations. The teams wanted to understand what German assessments had concluded and whether those conclusions had influenced tactical or strategic decisions. The answer was sobering. German engineers had identified the P-38's strengths accurately and comprehensively. They understood the climb rate advantage, the high-altitude performance benefits, the concentrated armament effectiveness. They had documented these findings in detailed reports, distributed to relevant commands. But the findings had generated no significant response, no major tactical revision to counter the Lightning's advantages, no acceleration of German fighter development to match American capabilities, no industrial prioritization to improve German fighter climb rates through better engines or lighter airframes. The reports had been acknowledged, filed, and essentially ignored. One Luftwaffe technical intelligence officer, questioned about why the P-38 evaluations hadn't prompted more urgent action, responded with resignation. "We knew the Americans had better fighters. We knew they had better engines, better fuel, better everything. Knowing this changed nothing. We couldn't build better engines because we lacked materials. We couldn't improve our fighters because our factories were being bombed. We couldn't change tactical doctrine because we didn't have enough pilots or fuel to train them properly. The reports told us we were losing a technical race. We had no capacity to win." That admission captured the essence of Germany's strategic situation by 1944. Technical intelligence about enemy capabilities was valuable only if you possessed the industrial and military capacity to respond effectively. Germany did not. The Luftwaffe's response to Allied air superiority focused increasingly on jet fighters, particularly the Me-262, which promised revolutionary performance advantages through pure speed. If German jets could fly 100 miles per hour faster than any Allied fighter, climb rates became less important. The jets could simply outrun pursuit, attack bombers, and escape before escorts could react. This wasn't entirely wrong strategically. The Me-262 did prove highly effective in the limited operations it conducted before war's end. But jet development came too late and in too few numbers to affect the strategic outcome. Meanwhile, conventional fighters like the P-38 continued escorting bomber formations deep into Germany, their climb rates allowing them to dominate the vertical fight against Bf 109 seconds and 190 seconds that increasingly flew with novice pilots, limited fuel, and inadequate training. The human cost of the climb rate gap became apparent in loss statistics. Luftwaffe fighter pilot training hours dropped steadily throughout 1944 as fuel shortages and operational demands compressed training programs. New pilots arrived at frontline squadrons with perhaps 120 to 150 hours total flying time, maybe 30 hours in type. American pilots, by contrast, typically had 300 hours or more before reaching combat squadrons, with extensive gunnery and tactical training. The combination of better-trained American pilots flying aircraft with superior climb performance proved devastating. German novice pilots, lacking the experience to exploit what tactical advantages their aircraft retained, faced opponents who could outclimb them to positions of advantage, then attack with overwhelming firepower. The learning curve for German fighter pilots became essentially vertical, survival beyond the first few missions increasingly unlikely. Individual German aces, men with hundreds of combat missions and dozens of kills, could still compete effectively. They knew how to extract maximum performance from their aircraft, how to position for advantage, when to attack and when to evade. But armies don't win wars with individual heroes. They win with effective average performance across entire forces. The average American P-38 pilot, competently trained and flying an aircraft with superior climb capability, defeated the average German pilot more often than not. The statistical aggregate of those individual combats determined strategic outcomes. By late 1944, the P-38's combat record in the Mediterranean and Pacific theaters was unambiguous. The aircraft had contributed decisively to air superiority in both theaters, its range and climb performance, allowing escort missions that made strategic bombing campaigns viable. In Europe, the picture was more complex. The P-38 suffered higher loss rates in the European theatre of operations than in other theatres, partly due to misemployment in rigid escort tactics, partly due to harsh weather conditions that challenged the Allison engines, and partly due to facing the Luftwaffe's most experienced and skilled fighter pilots. But even in Europe, the Lightning's impact was significant. Its presence forced German fighters to respect American escort capabilities, to approach bomber formations cautiously, to accept that attacking meant penetrating multiple layers of fighters that held altitude advantage. That caution translated into fewer bomber losses, which translated into more bombs on target, which translated into greater destruction of German war industry. The strategic bombing campaign's success rested on many factors: bomber defensive armament, fighter escort, range, improved tactics, overwhelming numbers. But within that complex equation, the P-38's ability to climb faster than German interceptors played a meaningful role in making bomber escort effective enough to sustain the campaign. Angelo Tondi's evaluation, written in the summer of 1943 and subsequently captured by German forces, had been precisely accurate. The P-38 Lightning represented advanced American engineering applied without compromise. Its climb rate exceeded Axis fighters. Its altitude performance was superior. Its range redefined escort missions. The report had identified a significant American advantage in fighter capability. What Tondi couldn't have known was that his report would be read by German engineers who possessed neither the industrial capacity nor the strategic flexibility to respond effectively. Technical intelligence without capacity for response becomes merely a catalogue of enemy advantages you cannot counter. In post-war interrogations, Oberleutnant Schmidt, who had analysed the P-38 data for Luftwaffe intelligence, reflected on what might have been done differently. We should have recognized earlier that the Americans were building fighters using industrial methods we couldn't match. They accepted weight and complexity in exchange for capability and reliability. We kept trying to build sophisticated, lightweight fighters with marginal advantages in specific parameters, while they built heavy fighters with comprehensive advantages across all parameters that mattered strategically. We were engineering masterpieces. They were engineering war winners. The difference proved decisive. That assessment cut to the philosophical core of why the P-38's climb rate mattered beyond its specific numerical advantage. It represented a design approach that prioritized practical combat effectiveness, accepting compromises in theoretical elegance to achieve superior real-world performance. The Lightning wasn't the most beautiful fighter. It wasn't the most aerodynamically refined. It wasn't the lightest or the most efficient in pure terms, but it climbed faster than its opponents, fought at altitudes they couldn't sustain, ranged farther than they could follow, and came home on one engine when battle damage would have killed a single-engine fighter. Those practical advantages accumulated across thousands of sorties into strategic significance that elegant engineering alone could never achieve. The final irony of the P-38 story emerged from production decisions. By September 1944, all but one of the 8th Air Force's P-38 groups had converted to P-51 Mustangs. The Mustang offered even longer range through better fuel efficiency, adequate climb performance, and superior high-altitude speed. The Lightning's era as the primary long-range escort fighter was ending, not because it had failed, but because American industry had produced something even better. Germany, meanwhile, still struggled to produce adequate numbers of conventional fighters, while betting desperately on jets that would arrive too late. The contrast captured the broader strategic reality. America could field the P-38, identify its limitations in specific operational contexts, develop a superior alternative in the P-51, and transition entire fighter groups to the new aircraft, all while maintaining overwhelming numerical superiority in the air. Germany could barely sustain production of existing designs, much less develop and field entirely new aircraft types in significant numbers. The P-38's climb rate advantage, documented so meticulously by Tondi and confirmed by German evaluations, represented just one dimension of Allied air superiority, but it was a dimension that mattered tactically, operationally, and strategically. It gave American pilots the ability to control altitude, which meant controlling engagement terms, which meant winning more fights, which meant fewer bombers lost, which meant more bombs on target, which meant Germany's industrial capacity ground steadily down despite desperate defensive efforts. In the end, the fork-tailed devil earned its reputation not through any single overwhelming advantage, but through the accumulation of practical combat capabilities that proved decisive when applied systematically across thousands of missions. The Lightning could climb faster than German fighters could follow. That simple fact, measured precisely in Tondi's report and confirmed at Rechlin, echoed through tactical decisions, operational planning, and strategic outcomes until the war's end. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.